The wind comes off a vanished coast that no map shows. The air tastes like salt and ancient ice. Ahead stretches a plain that today lies under the North Sea, a drowned country once called Doggerland by modern scientists. Waves now roll where families once walked. What if the first chapters of our story are sleeping out there under silt? You open a textbook and the line looks neat. Hunters. Villages. Cities. Then rockets. That line fits the last 6,000 years. It does not fit the last 300,000. If the Earth can swallow a country in 10,000 years, what could it swallow in 100,000? Picture the year 100,000 BCE. Not a fantasy. A date inside the last glacial cycle. Taller ice in Canada and Scandinavia. Sea level more than 100 meters lower than today. Britain connected to Europe. Indonesia tied by land to mainland Asia. The Bering Land Bridge opened between Siberia and Alaska. Could a coastline city built on those plains survive the long melt? We think we know because we see what remains. Stone. Bone. Cave art. We forget how fast the rest vanishes. Wood rots unless sealed. Textiles fall to dust. Iron becomes red flakes. Copper turns to green film. Concrete splits in frost. Even carved granite rounds off under rain. Time is a perfect thief. If we stopped maintaining New York today, trees would break the streets within a century. In 1,000 years towers would be open skeletons. In 10,000 the skyline would be a low hill of mixed sands and rust. What would be left in 100,000? Here is the central question. Could an advanced society have risen long before Sumer around 3,500 BCE or Egypt around 3,100 BCE and then fallen so completely that only the planet remembers? If that sounds impossible, ask a different question. Where would you look for proof after glaciers bulldozed continents and seas climbed 100 meters? We measure the past by what we have found, not by what once existed. Göbekli Tepe in southeastern Turkey surprised everyone when its megaliths dated to roughly 9600 to 8200 BCE. For thousands of years those pillars slept under their own burial fill. A temple hill hiding in plain sight. If a site that young stayed hidden until the 1990s, how many older places wait under alluvium, dunes, or surf? The Ice Age did not freeze the tropics. It shifted rains and coasts. River mouths sat farther out on the continental shelves. Those shelves are now under wave chop and marine mud. Archaeology mostly works where we can stand and dig. How much human story sits out on the floor of the Gulf of Thailand or the Persian Gulf or the Sunda Shelf, quiet under meters of silt? A twist comes from geology. The crust moves. Africa grinds north into Europe. The Himalaya keeps rising. The East African rift widens grain by grain. Plates carry cities like luggage and then drop them into subduction zones. Over long time a street becomes a metamorphic band. Would we recognize a plaza pressed into schist? Scientists asked a wild but serious question in 2018. If an industrial civilization had existed long before us, what signature would remain? The paper had a playful name among readers, the Silurian idea, but the method was sober. Do not hunt for statues. Hunt for chemistry. Carbon spikes in sediments. Odd isotopes. Synthetic molecules that do not appear in nature. If such fingerprints can mark our age in future rocks, could similar fingerprints mark a lost age in past layers? Now think about scale. We assume advanced means global. What if it did not? What if it meant regional mastery with clean energy and biodegradable materials? A culture that engineered with plant composites stronger than steel but designed to return to soil within decades. That would be brilliant stewardship. It would also be terrible for archaeologists. What remains when the best technology chooses to leave no trace? We can ground the imagination without fantasy. The Toba supereruption in Sumatra about 74,000 years ago was real. Ash fell over the Indian Ocean basin. Climate cooled for years. Genetic studies debate the size of the human bottleneck that followed. The point is simple. The planet throws events that can end an era. If a thriving coastal culture sat near Sunda at the wrong time, how much would survive a column of fire and years of hungry skies? Not every disaster is explosive. Slow sea rise can erase a civilization more thoroughly than war. Imagine a network of light towns strung along a Pleistocene coast on what is now the South China Sea shelf. As meltwater lakes in North America drained and seas climbed centimeter by centimeter, those towns would move upslope or vanish. The last foundations would lie today under trawler nets and silt. We read myths for meaning and sometimes for memory. Aboriginal Australian stories describe coasts that later went under water since the end of the last ice age. Greek philosophy carries a bright island that fell in a day and a night. India holds flood epics older than the Mahabharata. The details shift, but the pattern repeats. A shining place. A fall. A world made new. Are these only parables, or do they hold the outline of events retold across many tongues? You do not need a lost super city to make the question matter. Humanity has existed for at least 300,000 years. Recorded writing covers 5,000. That is less than 2% of our time as a species. For 98% of our story we rely on what the planet happened to save. Could the largest gap hide more than we have dared to imagine? Another reveal sits in the way we search. Funding follows expectation. Digs go where sites already exist. Excavations stop at late Holocene and early Holocene horizons because budgets run out. We rarely cut deeper unless there is a reason. We rarely core beyond the soft layers. What if a reason is waiting at 20 meters, silent in Pleistocene clays? You step back to that wind on the drowned plain. The waves cover an older map. The question feels bigger now. Not did it happen, but how would we even know if it did? That is the hook that holds the mind. The idea that the earth keeps the secrets of its makers as well as their bones. Here is the path ahead. We test our timeline. We map the places time hides best. We define the traces an invisible civilization would leave without metal or plastic or towers. We separate myth from memory without killing wonder. We ask what would end such a world and what that means for ours. The ocean breathes. The beach you know today was a field in 12,000 BCE. The city you love could be a sandbar in the future. If this has happened before, the lesson is not despair. It is humility. It is also urgency. If we are not the first, we might not be the last. What we leave in stone and chemistry will be the only testimony that time cannot erase. Start with a room under a hillside. It is dry, stable, and dark. Inside lies a bundle of woven plant fiber older than the first bricks of Jericho. We will never see it because the hillside fell centuries ago and a river carried the room away. Archaeology is a science of survivors. Survivors are not neutral. They are a tiny sample that time selected. Our story of the past is built on stone and pottery because stone and pottery last. That does not mean people loved stone and pottery more than wood, leather, fiber, and glue. It means the moist and living world recycled the rest. When we say there is no evidence for towns before agriculture around 10,000 to 12,000 years ago, we are really saying the conditions that keep wood and straw intact are rare. Consider radiocarbon dates for the first clear fields in the Fertile Crescent. 10 to 12 millennia before present. Consider the earliest large cities we agree on. Uruk in southern Mesopotamia around 3500 BCE. Memphis along the Nile soon after 3100 BCE. Mohenjo-Daro on the Indus by the 3rd millennium BCE. This feels solid because bricks remain and writing remains. Now consider the span between 300,000 and 15,000 years ago. Most of that world lies in layers few shovels ever touch. Erosion scrubs. Sediment buries. Plants tear and bind. Glaciers grind. Earthquakes lift and drop. Over 100 millennia those forces win every time. Even the Great Pyramids, built of limestone blocks with faces oriented to the sky, would smooth and lose detail under endless wet seasons. Angkor shows the other path. The jungle reclaims walls within centuries. If the canals had been cut 2,000 years earlier, rain and roots would have taken them. What then of lighter towns on the Sunda Shelf or the Persian Gulf floor that had no stone at all? The continental shelves are the largest museum we have not opened. During the last glacial maximum around 21,000 years ago, shorelines sat far out. People love shorelines. Rivers offer fish and fertile silt. Estuaries offer shelter. If early complex societies existed, coasts would be their first spine. Those coasts are now underwater. Sonar maps parts of them. Most areas remain only roughly known. Could whole river systems with villages and workshops lie under the Bay of Bengal mud? We can check the scale. More than 20 million square kilometers of land flooded as the last ice age ended. A continent's worth of plains became seabed. To see that land today, you need boats, multi-beam sonar, cores, and time. Underwater work is expensive. Storms erase the shallow layers. Sand moves like liquid across banks. Even when a team finds a drowned Mesolithic camp in the North Sea or a Neolithic hearth off the Israeli coast, those finds sit in the last 12,000 years. Push back another 80,000 and you reach depths and distances that few missions attempt. There is another bias we rarely admit. We look for reflections of our own world. We expect quarries, slag heaps, fired bricks, high-temperature ceramics, long straight roads. We forget that advancement can be soft. A culture might have mastered plant resins, cellulose composites, fungal mycelium structures, and genetically tuned crops that leave almost nothing inorganic. Such excellence would alter forests and soils but would not build a stone skyline. Would we recognize that footprint without expecting it? Twist the lens again. The clearest long-term traces are not walls. They are geochemical hints. Stable carbon isotopes can record heavy burning of biomass or fossil carbon. Nitrogen isotopes can record intensive agriculture. Synthetic halocarbons can mark refrigerants. Some fluorinated compounds can persist for tens of thousands of years. If a past industrial phase had produced unusual molecules, a thin layer in a core could hold them like a time signature. Have we looked widely enough at Pleistocene cores with that possibility in mind? Some layers tell abrupt stories. The Younger Dryas cooling event began around 12,900 years ago and ended near 11,700 years ago. Greenland ice holds the shift in bubbles and dust. Volcanic layers in many cores carry the dates of eruptions. Toba ash sits in the Indian Ocean in South Asia. We can match climates to sediments. If a civilization altered a region's atmosphere or soils in 100,000 BCE, a regional core might remember. Yet cores are sparse outside a few well-studied basins. There is a counterpoint. Extraordinary claims demand extraordinary evidence. The Antikythera mechanism shocked historians because it showed Greek engineering around 200 BCE that used differential gears to model celestial cycles. It did not rewrite prehistory. It changed our sense of a timeline within the last 2,000 years. The London hammer story and nails and stone tales do not stand up to controlled context and dating. The challenge is not that evidence cannot exist. The challenge is that chains of custody and stratigraphic clarity are fragile. A better path asks where preservation is most likely. Caves with stable temperatures. Deep anoxic mud where oxygen cannot chew organics. Peat bogs that tan flesh and seal wood. Permafrost that locks tools. Lake bottoms that collect year-by-year laminations called varves. Submarine canyon fans that receive steady silt. If we target these with the right questions, we can widen the search beyond pottery and flint. The question keeps returning. What would we count as proof? A single object with unknown alloy found on a shoreline is not enough. A cluster of anomalies across a dated layer could be a suite of non-natural polymers in a 100,000-year horizon across several basins. A sharp step in carbon isotopes consistent with massive energy use unrelated to climate cycles. A repeating pattern of microplastics where there should be none. Even then we would argue for years because the stakes are high. We need to hold two ideas at once. Skepticism protects the record from wishful thinking. Openness protects the record from blind spots. The way to balance both is method. Define signatures before you hunt them. Publish negative results. Core shelves where models predict Pleistocene rivers. Drill periglacial lake beds that never overturned. Scan for compounds that only industry makes. If we find nothing, we learn. If we find oddities, we test again. Return to the hillside room carried off by the river. The past is full of rooms like that, uncounted and uncountable. Our timeline is clean because the planet cleaned it. The bias of what survives is not a flaw in archaeology. It is a fact of nature. Knowing that, we can build a better search. We can also read our own cities with new humility. The things we build to last may be the things the future never sees. The things the future sees may be the things we never meant to leave. Begin with a map that no one drew. It lies on the seabed, etched by rivers that now carry only fish and cold light. Channels snake across the Sunda Shelf south of Vietnam and west of Borneo, deep grooves carved when sea level stood more than 100 meters lower. Between about 21,000 and 11,000 years ago those channels fed deltas as large as any today. If a network of settlements lined those banks, where would their hearts rest now? Sea level rise did not come like a single wave. It came in pulses that the planet still remembers. Meltwater Pulse 1A is a name modern science gives to a jump that happened roughly 14,700 years ago. In about 3 to 5 centuries the ocean climbed several meters to perhaps 20 meters worldwide. Coasts retreated faster than a person could walk in a lifetime. Could a shoreline culture hold its ground under that kind of relentless step? You can see the drowned rivers in bathymetry. The South China Sea shows the Palea Red River and the Palea Mekong as faint blue scars. The Persian Gulf shows an ancient trunk stream that once cut a green valley from the Tigris and Euphrates toward the Gulf of Oman. The North Sea shows Dogger Bank like a shoulder of land that once rose dry. These shapes are not rumors. They are maps. If people followed water then people followed these lines. Archaeologists have begun to pull proof from the shallow margins. Off the British coast trawlers have brought up Mesolithic bone points from banks that were once marsh and birch. Off Israel the submerged village at Atlit Yam preserves a stone circle and wells dating to around 7000 BCE. Off Florida peat layers with wooden stakes rest under salt and date to early Holocene millennia. These finds sit near the shoreline of the last 12,000 years. Push back further and the museum lies deeper and darker. The twist is not emptiness. It is depth. Many Pleistocene deltas lie beyond scuba range under meters of silt that shift with monsoon storms. Sand waves migrate across seabeds like slow rivers. A ceramic shard can move kilometers. An organic bowl becomes food for microbes unless buried in anoxic mud. Even when conditions are perfect, access is rare and budgets are thin. Look east toward the Great Fan at the mouth of the industry. In the early Holocene the delta laced channels across what is now the Gulf of Kutch and the Rann of Koch. Earlier still, during lower seas, its reach extended farther. To the west lies the Arabian Sea oxygen minimum zone where organic matter falls and stays. A core through that slope holds annual laminations in places. If any chemical oddity marked human activity older than Harappa, a thin band could hide it there. Turn north to the Black Sea. Its deep layers are anoxic even now. Shores here experienced dramatic changes when Mediterranean water rushed in after the Ice Age. Along Crimea and the Turkish coast lie submerged terraces that once saw daylight. Wooden hulls have survived in deep cold because rot cannot breathe there. If ships from the last few thousand years can sleep intact, what else might rest in deeper strata waiting for a narrow drill to touch? Bathymetry reveals more than old rivers. It shows abandoned meanders and oxbows on the shelf. It shows terraces cut by wave bases far below modern storm depth. Each terrace is a coastline that lasted long enough for waves to carve a step. Each step could have held a string of camps, gardens, and docks. The steps stack like a staircase down into time. Which step hides the oldest footprint? Why expect complexity before known agriculture? Shorelines offer an economy without large fields. Tidal flats breed shellfish. Estuaries pulse with fish. River mouths carry flood silt that makes small gardens worth the work even without cereals. A community could live well on coasts with knowledge rather than acreage. Knowledge leaves lighter scars than walls. There is another clue that coasts were busy far beyond the textbook sequence. Human dispersal into Sahul, the combined Pleistocene landmass of Australia and New Guinea, required crossings from Wallacea at least 50,000 years ago. Rafts or boats existed then even if built from plants and fiber. Once people move by water they build water knowledge fast. A blue highway encourages exchange, story, and skill. Does a coastline trading world look advanced in ruins if its craft all return to soil? Measurements keep the story honest. Ice core records from Antarctica show sea level response in stages. Coral terraces on Barbados and Tahiti preserve dates for rises as reefs grew upward to stay in sunlight. Drowned river valleys on continental margins match those jumps. There is nothing mythic about the geography. What is unknown is the human layer that rode those curves. Now imagine a team with the right tools and a stubborn plan. High-resolution multi-beam reveals shelf channels in detail. Sub-bottom profilers trace buried surfaces beneath the mud. Targeted cores pull up cylinders that capture pollen, soot, microchar, and chemistry. A handful of places from the South China Sea to the Arafura Shelf to the Bay of Biscay yield layers with odd spikes not explained by climate alone. Would that be enough to reopen the case? Even if the shelves are empty of surprises, the exercise matters. It forces us to fill blank spaces on the human map. The last glacial cycle redrew coasts across every ocean. People were there to witness it. Many walked away as the water rose. Many stayed as long as they could and then left markers that waves rearranged. We will never know their names. We can still learn the shape of their world. The ocean borrowed those towns and does not hurry to return them. It leaves hints on sonar screens and in fishermen's nets and in odd lines on old charts. It leaves a feeling that the edge of the continent carries a story like a book with wet pages. You can still read some chapters if you hold them at the right angle. The rest will remain salt and guesswork. One last question. If the biggest museum case on Earth lies offshore, what does it say about our idea of completeness? We tell ourselves the record is almost full. The seabed says the opposite. Until we read it, we should speak about certainty with care. The towns are quiet under silt and cold light, exactly where the map ends today. A statue falls and becomes gravel. A molecule can outlive a kingdom. When geologists speak of signatures they mean faint chemical whispers trapped in rock and mud. Those whispers decide whether a story is rumor or record. If a civilization once burned and mined and manufactured on a grand scale, something of that behavior should have stained the sediments that formed in its time. Start with carbon. Plants prefer lighter carbon. When vast amounts of ancient carbon from coal or oil burn, the balance between light and heavy carbon in the air and in the ocean shifts. That balance is written as delta 13C in cores. Our age drives a sharp negative step that future readers will see. If another pulse appears in Pleistocene layers where climate models do not expect it, we would have questions to ask and tests to run. Nitrogen keeps notes. Intensive farming alters soil nitrogen in ways that travel down rivers and settle in lakes and estuaries. Layers rich in algae and poor in oxygen follow. Those layers show heavier nitrogen values. If centuries of deliberate fertilization happened far earlier than we think, a lake that never fully mixed could carry that signal grain by grain. There are molecules that nature rarely makes. Long-lived fluorinated compounds persist from factory to fish to mud. Some industrial chlorinated compounds do the same. Microplastic fibers and fragments snow from the sky today and sift into mountain snows and polar ice. In warm places they break to dust. In cold places they last. Finding plastic in a very old layer would be stunning. Finding synthetic fluorinated ghosts would be quieter and perhaps more plausible. It would also be hard to explain without human hands. Isotopes born in reactors and weapons tests are another kind of clock. Plutonium-239 has a half-life near 24,000 years. Americium-241 sits on a similar scale. In 100,000 years several half-lives pass. The atoms thin but do not vanish. An industrial era with fission would have salted local soils and river mouths with a ratio of isotopes that does not occur in nature. The ratio could still be resolved with careful instruments if the right core was found and the layer has not been washed away. There is even a rock born from our plastic age. On Hawaiian beaches researchers described plastiglomerate, a fused mix of melted plastic and sand and shells. If a past culture ever made a similar fusion with another polymer, it might sit as pebbles in a thin layer and look odd to a trained eye. The problem is that odd stones without context are curiosities, not proofs. The context must come first. Where do we look for chemical memory that reaches across 100 millennia? Antarctic ice holds bubbles and dust back to 800,000 years in some cores. Each meter steps through thousands of winters. Desert loess in northern China and the American Midwest holds dust that fell year after year from glacial winds. Lake Baikal and the Dead Sea keep laminated stories in their depths. The Santa Barbara Basin off California records oxygen-poor layers through time. The more stable the basin, the cleaner the signal. We should also mind false positives. Wildfires on a continental scale can drive carbon and nitrogen shifts. Volcanoes can lay down halogens and metals. Meteor spurts can deliver odd bits. A field test must compare many cores along a path of water and wind. A lone spike invites wishful thinking. A suite of matching shifts invites careful excitement. Scientists have built toolkits for this. Gas chromatography separates and identifies complex molecules. Accelerator mass spectrometry counts rare isotopes in a handful of atoms. Raman spectroscopy can fingerprint microplastics and resins inside ice or clay. Pollen analysis can reconstruct what plants grew when and whether human preference shaped the mix. Charcoal counts can track burning in forests and grasslands far beyond any one campfire. Together these methods can ask a clean question. Did an unusual signal rise and fall across a region in a way that only people can explain? Add another witness that bridges rock and story. Lake Suigetsu in Japan holds varves that reach beyond 50,000 years. Each pair of light and dark bands marks a year. Pollen counts there resolve slow changes in forests that do not match simple temperature swings. When people harvest and burn and plant, the pollen ledger shifts. A modest change across centuries becomes a paragraph in mud that no eye could have seen while it was written. Caves add a different chemistry. Fatty acids from skin and smoke can lodge in sediments on floors where people sat and made tools. Ancient DNA now appears in cave dust where no bones remain. If a cave floor that saw humans around 100,000 years ago also shows a mix of plant DNA from orchards outside in the same span, the weight of the hint grows. It is still a hint. It is also a place to trench above and to sample soils with care. Fold in one more twist. What if an advanced culture did not use petroleum and heavy industry? What if the chemistry of their age looks clean compared to ours? Then signatures would be subtle. Perhaps a long gentle enrichment in soil nitrogen from managed wetlands rather than inland deserts. Perhaps a steady decline in fire frequency in a region where humans learned to break the old lightning rhythm. Perhaps plant pollens moving upslope without matching temperature change because people terraced hills and managed water across seasons. We do not need certainty to benefit. A deliberate global survey of Pleistocene basins focused on non-natural molecules and cycle shifts would give us a map of the quiet background of Earth. That map would improve models for climate, fire, and life long before it solved mysteries. If a few pieces look out of place after every natural explanation is tried, then we have something worthy of debate rather than daydream. The planet does not forge stories to please us. It keeps what physics allows. It keeps tiny clues with a loyalty that stone statues cannot match. Chemistry is where history goes when monuments fail. If a lost chapter existed and if it worked with fire or factories or farms, chemistry is the witness most likely to point a hand toward the right page. Most of our picture of advancement is a mirror. We see tall buildings and metal veins and glowing grids. We forget that intelligence can prefer lightness. Imagine a society that designs for return rather than persistence. Its pride is not in monuments. Its pride is in leaving a valley as rich 20 generations later as the day it was settled. Start with materials. Plants build cellulose and lignin with solar energy and air. Fungi weave chitin and complex sugars into flexible structures. Modern labs already press mycelium into panels and grow bamboo into beams. Imagine a lineage that learned similar tricks 50,000 years ago and refined them over centuries. The frames of homes would be strong and dry. Their end of life would be soil food. No rubble piles to argue with the rain. Only darker earth where villages once stood. Think about energy. A coast culture with strong tides and reliable winds needs no coal. A rift valley with consistent geothermal vents needs no oil. Even far from coasts, running water and sun can power light industry when designs fit the sources. A people who measure prosperity by leisure and resilience rather than output would reject giant systems in favor of neighborhoods that manage their own need. A blackout would be a local story, not a national crisis. What would a satellite see of such a world? A scatter of small lights and none at all in towns that chose the dark. Transport could be the quietest part. If communities are nearly self-sufficient, flows are seasonal and small. Boats move along rivers and sheltered coasts. Paths follow ridges and animal tracks. Roads are not paved. They are negotiated. A road like that leaves a different fossil. Disturbed soil horizons. Changed compaction in a meter of dirt. Pollen from moved crops along a trail. These are real traces, but they require lab eyes and context to reveal intent. Knowledge would live in hands and memory. Writing is a powerful tool but not the only one. String figures can encode instruction. Songs can encode timing for irrigation. Carved sticks can encode count. Quipu systems in the Andes show how chords remember numbers without ink. Polynesian stick charts show how swells and stars map the Pacific without drawings on bark. A society that valued redundancy would teach its children through work and weather and ritual. When forced to move, it would carry everything important in minds and in small durable bundles. This picture is not fantasy without anchor. Dark earths in the Amazon known as terra preta are anthropogenic soils rich in charcoal and nutrients created within the last few millennia. They hold fertility for centuries because microscopic carbon locks in. In New Guinea highlands, people reshaped wetlands for gardens thousands of years ago. In the American Southeast, long before heavy plows, people built fish weirs in rivers from wood and stones that guided migrations for seasons. These are small-scale and recent compared to 100,000 years. They show a principle. Knowledge can make landscapes generous without skyscrapers. Shift the lens further back. If a valley shows a long, unusual balance of species without matching climate drivers, humans may be the missing factor. A steady presence of fruit trees far beyond what random dispersal makes. A mosaic of fire scars showing regular cool burns timed to seasons rather than lightning. Charcoal signals that rise on a schedule and fall when rains should have brought sparks. Those are signs of stewardship. They are also hard to spot without deciding to look for them. Twist the story once more. Lethal events shape choices. If a community remembers ash winters, it designs for retreat. Temporary buildings. Seed banks buried on high ground. Library bundles stored in caves that hold cool dry air. When danger comes, the town lifts itself and walks. Generations later the cave burns to dust or floods and the record becomes unreadable. The plan worked for survival and failed for archaeology. Success for one is failure for the other. Why would such a civilization abandon metal? Perhaps it never loved it. Copper and iron take heat and fuel. Smelting scars hillsides and makes smoke. If your materials library already includes resins and fibers and stone flakes that can be recast with heat from charcoal, why open a scar in the mountain? If you do use metal, you recycle it until only stains in soil remain. A clean loop leaves no slag heaps. Our future designers dream of that loop. An older culture might have lived it. Skeptics will say that complexity scales with population and surplus. That is often true in textbooks built on the last 6,000 years. There is another path. Complexity can live in networks of small high-skill groups that trade across seasons and share knowledge at gatherings. The evidence becomes calendar sites and ritual grounds rather than capitals. The genome carries mixing from wide circles. The land carries light footprints that last because they fit rather than fight. Measurement can test parts of this picture. Pollen cores can reveal orchards where climate would not predict them. Soot profiles can show cool burns rather than crown fires. Stable carbon in soils can show long inputs of char without cities nearby. Phytoliths can show crops grown on terraces long since eroded. Isotopes in human bones can show seasonal diets from freshwater and sea that match travel and exchange. None of these prove laboratories. All of these can prove design. The absence of walls is not the absence of intention. The absence of slag is not the absence of craft. If we expect a mirror we will find only our reflection. If we expect a cousin we may finally notice the shape of another face in the dim. A civilization that refused to leave ruins could be the hardest to recognize and the most relevant to learn from. It leaves us with a final quiet question. If the wisest way to live on a restless planet is to make almost nothing permanent, are we the anomaly rather than the rule? Are we the loud chapter between long quieter ones? The answer matters because it changes what we think it means to advance. It also changes how we should search for those who went before. Some places hide time better than stone. They hold cold or stillness so deep that life moves slowly and metal does not rust. If anything from a very old chapter survived it would likely sleep in one of 3 vaults. Under ice that never melts. Inside caves that never flood. Beneath waters that kill oxygen and lock layers like pages in a book. Begin with ice. Domed sea in Antarctica gave a climate record that reaches back around 800,000 years. Tiny bubbles hold ancient air. Dust layers record winds and droughts. Volcanic ash marks days when the sky went dark. Greenland holds shorter but still powerful stories, with abrupt jumps like the Younger Dryas cooling written as changes in trapped gases and isotopes. Ice will not hold a tool from 100,000 years ago unless it fell into a crevasse and stayed frozen. It will hold the rhythm of the age that wrapped any tool that once existed. Under the ice sheets lies bedrock that has not seen rain in ages. Radar maps show mountains and valleys. Subglacial lakes like Vostok sit sealed under kilometers of ice with waters isolated for very long spans. If a valley floor under East Antarctica once held forests before ice marched over it, the sediments beneath that ice would be an archive no trowel can touch without extreme drills. A few projects have reached shallow beds. A future mission could reach deeper. Caves preserve for different reasons. Temperatures remain stable. Drip water builds stone slowly and seals rooms. Dry caves in the Levant have kept baskets for thousands of years. Caves in the Sierra de Atapuerca in Spain have saved human bones for hundreds of thousands of years. Altamira and Chauvet kept paintings safe through ice and thaw. Go back farther and the odds drop. Yet caves also act as libraries for sediments blown in from outside. Pollen grinds in and stays. Soot streaks can reveal seasons of fire. Null marks on bones can reveal occupations by people and by animals. A floor that sits quiet year after year can become a quiet ledger of life above. Speleothems grow like patient calendars. As calcite lays down, it takes in tiny amounts of trace elements that reflect what flowed over ground above. Magnesium can track dry spells. Uranium series dating can nail timelines far earlier than radiocarbon can reach. A speleothem that shows decades of unusual chemistry at 100,000 years ago could tie to land use above even if no artifact sits nearby. It is not proof of cities. It is a lead worth following on the surface. Anoxic basins at sea and on land keep finer pages. The Black Sea deep waters lack oxygen, so would ships rest there. The Carriaco Basin off Venezuela stacks dark and light laminae year by year. The Santa Barbara Basin holds histories of coastal upwelling and die-offs. In lakes with similar stillness, a pin can count winters as rings. A thin burn layer sits above a thin algae bloom sits above a dusting of pollen. If a century of unusual soot falls with a specific chemical fingerprint, that is a paragraph we can read again and again. Permafrost is another keeper. In Siberia and Alaska, bones with hair still on them fall from river banks as thaw advances. Wood tools have emerged from Yukon ground where ice has locked them since before the last maximum of cold. Bluefish caves in the Yukon hold cut marks on bones dated near 24,000 years ago, a sign that humans weathered the last ice advance in pockets. Push back beyond 50,000 and the permafrost record thins, but in the highest and coldest zones ground can hold what warmer places erase. The challenge with all vaults is access and context. Drilling deep ice requires clean rooms on snow. Coring an anoxic basin demands ships, quiet winches, and patience. Cave work needs careful mapping because sediments mix in ways that trick the eye. Even when the sample is perfect, nature has many ways to mimic us. Wildfires leave soot. Volcanoes leave fluorine. Desert winds leave microplastic-like fibers made by plants. Every claim needs twin controls and a lab that welcomes disagreement. What would a smart search look like? Teams would map shelf rivers and pick the easiest stair steps for first passes. Another group would rank lakes by age, depth, and mixing, then pull pilot cores to read quick histories. Cave researchers would scan speleothems at scales rarely tried and tie spikes to outside soils with trenches. Ice teams would target layers near known climate calm periods to hunt for signals that weather alone cannot make. Each strand would run blind and publish regardless of hit or miss. The pattern across all strands would be the result. We should not ignore the human side. Local knowledge knows where rivers cut old ground. Fishers know where nets snag on lines that are not rock. Cavers know which hills breathe dry air in summer and hold silence in winter. The best projects listen before they drill. A lead from a community can save years of wandering with machines. Call this work patient optimism. We may find only the planet we already know, written more clearly. That would still be a gift. We would close gaps in the Ice Age story that today we fill with guesswork. Or we may find a layer that does not fit the chorus of winds and ashes and currents. A quiet signal of people where books say none should be. That would not end an argument. It would begin an honest one. If any artifact sleeps in those vaults, it will be small. A fiber sheet pressed with a pattern too regular for chance. A shard of composite with plant cells locked in a polymer we do not recognize. A thread with dyes that never occur in nature. The thing itself will be humble. The weight will come from where it lies and what lies with it. The ice and mud do not promise answers. They promise that if answers exist, they will be kept as well as physics allows. On a planet that recycles everything, these are the closets that sometimes forget to empty themselves. If we are serious about the deepest chapters, we will have to open them, one careful hinge at a time. A single day can bend a century. A single year can change a species. Picture a quiet morning on the island we now call Sumatra. The year is about 74,000 years ago. The mountain named Toba is restless beneath a lake. When it breaks, the sky goes the color of wet stone and the air fills with needles of ash. The blast sends columns higher than any storm and paints the Indian Ocean basin with glass and cinder. We measure the result in layers. Ash blankets India and the Bay of Bengal. Tiny shards lodge in cores taken from the Arabian Sea. Sulfate rises in Antarctic ice. The eruption was among the largest of the last 2 million years. Temperatures fell for years. Plants faltered. Monsoons shifted. Could a coastal culture have weathered a sky that dim for that long? The Storegga slides came later and closer to our own post-glacial world. Along the coast of Norway about 8,200 years ago a submarine slope failed and walls of water ran across the North Atlantic margins. Scotland and the Shetlands took waves that crossed dunes and marsh. Doggerland lost more ground to sea. A community could survive a storm and rebuild. Could it survive a wall of water that arrived without warning when the seafloor moved? Glacial lakes store another kind of catastrophe. At the close of the Ice Age, the Laurentide ice sheet held back inland seas in North America. One of those lakes drained catastrophically and freshened the North Atlantic. Climate cooled for a century around 8,200 years ago. Farmers in the Fertile Crescent felt seasons shift. If a coastal network relied on predictable winds and rains, a small change in storm tracks could break the calendar they used to live. Impacts are the darkest of dice throws. The crater at Chicxulub in Mexico ended the Cretaceous 66 million years ago. We have no event like that in the last 100,000 years. Smaller strikes still matter. In Siberia in 1908 a blast flattened taiga near the Tunguska River. In 2013 a meteor over Chelyabinsk showered windows with glass. A medium strike over water could make tsunamis across basins. Over land it could seed fire. Do we know every small scar after ice sheets and rivers have planed the ground and filled the craters with silt for thousands of seasons? Even without a single dramatic blow the planet can add harms together. A century with 2 or 3 bad harvests can drain a surplus. A string of earthquakes can drive a coastal people back from cliffs and harbors. A disease can travel through trading circles that meet at seasonal fairs. The pace of collapse is often slower than the moment a tale remembers. Memory turns a decade into a night because the world feels different when you are the one who has to run. History within writing offers rehearsal. After 1200 BCE many palace societies around the eastern Mediterranean fell or shrank. Mycenae weakened. Ugarit burned. Trade webs broke. Writing systems shifted or were forgotten. The Greek world entered centuries we call a dark age because texts go thin. That was a regional disruption that left ruins we can still read. Now push the pattern back and remove stone and replace ink with song. What would remain when the language that held the song changes and the singers no longer remember the meter that held the tale together? There is a human response that repeats across time. When the sky turns strange people turn to high ground and to caves. They cache tools. They store food. They pack stories into rituals. They simplify and wait. Skills with narrow uses die first. Skills with daily uses travel. A craft like making plant cord or fish traps follows families across valleys and survives even when towns do not. A science like modeling tides may fade if boats stop moving between headlands for a few generations. The reset does not need fire to erase a ledger. It needs silence. A library without readers becomes a stack of tinder. A workshop without apprentices becomes a locked door. The door rots. The hill slumps. The stream takes the floor downhill grain by grain. A century later a traveler crosses a gentle meadow and never knows 1,000 lives once converged here with calendars and debts and names. We anchor this with numbers. Ash from Toba reaches meters thick near the vent and thins to millimeters across South Asia. The 8.2 kilo-year event shows in Greenland as a drop in oxygen isotopes. The Storegga tsunami left sand sheets over peats that date to the early Holocene. These are measurable realities. They are also reminders that the planet can reset coastal maps and growing seasons on schedules that ignore our plans. If a society thrived in a stable pocket a long time ago, the shock that ended it may have been local rather than global. A regional drought in East Africa. A volcanic decade in the Aegean. A salt intrusion up a delta that ruined crops for a lifetime. Collapse stacks from many small misfits as easily as from one big blow. The end feels the same to those who live it. The signs for us are thinner. Every reset carries lessons for search. Target terraces above old coasts that would have been safe harbors after a flood. Target upland caves near fertile valleys where refugees would store durable knowledge. Target lake basins that sat downwind of a people who farmed. The fallout of a vanished world is not just ash and sand. It is patterns in pollen and soot and bones that forgot their names. We are drawn to the spectacular because it tells fast stories. The deeper pattern is patient. A world resets piece by piece until the last craft that holds the rest together gives way. Then the survivors make a smaller plan and teach it to their children. If this happened once before, we are not reading a legend. We are reading a manual written in reverse. A forge cools faster than a language. A language cools faster than a habit. After a break, the first thing to go is the uncommon tool. The last thing to go is the everyday song. We can watch this in eras we know. Then we can imagine the same forces playing for stakes we can barely count. When palaces fell around 1200 BCE in the Aegean world, scribes stopped writing on clay in Linear B except in a few places. Centuries passed before a new alphabet spread. The stories continued in voices by fires and in courts. When writing returned, the gods had new names and the old tally marks had no readers left. A gap in ink feels like a gap in mind. It is not. It is a gap in one technology of memory. Rome knew a secret in its concrete. Volcanic ash in a lime mix makes stone that heals in seawater. Ports built with it outlasted empires. The recipe thinned and vanished as trade shifted. 15 centuries later, builders rediscovered pieces of it. The Antikythera device shows another fade. A hand-powered computer with bronze gears sank around the 2nd century BCE. Nothing else like it survives from the next 1,000 years. Skill can climb to a bright point and then step down for reasons that have little to do with ability and much to do with trade, war, and luck. The Library of Alexandria is a symbol whether or not any single fire ended it. Collections scattered. Teachers moved. Scrolls decayed when maintenance failed. Knowledge travels with people and paper. It also travels with practice. Polynesian navigators carried sky and swell maps in memory across the Pacific for centuries. Colonial rule and new tools broke apprenticeships in some islands. In a few places those maps are being taught again now. The point is not nostalgia. The point is that instruction chain in 2 or 3 places. Now stretch the gap. Oral traditions can keep astonishing detail for thousands of years when they matter to survival. Aboriginal Australian stories keep maps of coasts that flooded after the last ice age. On the other side, names of local hills can be lost in 2 generations if people move to a river town and stop hurting there. If a flood scattered a coastal culture 100,000 years ago, which parts of its encyclopedia would cling longest? Which parts would fade before the second winter? Complex crafts are pyramids of steps. Smelting takes special clays, bellows, fuels, ores, and a sense of heat learned by skin and sight. If any link disappears, the rest makes less sense. A metallurgist without ore becomes a storyteller. A potter without temper becomes a cook. A boat builder without pine resin becomes a farmer. The skills do not die in an instant. They settle into simpler forms that meet the next day's needs. After a few lifetimes the memory of the higher step becomes a story about elders and luck. We can test how thin chains can be. After the Western Empire fell in late antiquity, some cities kept baths and pipes. Others bricked up aqueducts for defense. Stonemasons in one valley remembered arch forms while neighbors stacked flat stones for a century and then forgot the smoother method existed. In Mesoamerica the skill to build corbelled vaults traveled along certain polities and then winked out in regions where wars cut trade. These are young examples. They show how easy it is to break a staircase with a few missing steps. Writing stabilizes instruction but depends on institutions. Scribes need schools and time and food. If a world shrinks to bare survival, texts become kindling and leather becomes useful for sandals. After the shrink, the first books to return are those that help crops and contracts and boundaries. Astronomy returns if boats return. Math deepens if surplus and trade return. A culture can climb again. The second climb does not prove the first never happened. Museums hide another kind of amnesia. Drawers hold thousands of objects with poor provenance. A bead sits with a label from a site long eroded. A fragment of resin sits in a bag tagged unknown. When budgets are thin, those drawers stay closed. Digital tools can help. Imaging and mass spectrometry can scan collections for patterns curators did not know to seek. A composite shard from a very old layer might be waiting under fluorescent lights in a back room, misdated decades ago and never tested for the chemistry they carry. Consider languages as carriers of tech. Words for knots and weirs and terrace walls can persist where the tools do not. Loan words reveal trade even after cargoes stop. If a set of unusual agricultural terms pops up in a region where farming starts late in the archaeological record, the words might be older than the fields. Glottochronology is a blunt instrument. Combined with soils and pollen and dated charcoal, language can place shadows on a ground where we have no bodies. The return of knowledge is never a mirror of what went before. New hands shape old ideas to fit new landscapes. If a coastal science migrated inland, it would be reborn as water management, not as sailing. If a lunar calendar for tides moved to a mountain range, it might survive as a festival cycle or a seed ritual. The practice looks like myth until someone notices the numbers hidden in it. Then history changes quietly in a footnote and a field guide. There is a responsibility that comes with this view. If knowledge can vanish for centuries, we should design our own storehouses for hard times. Multiple media. Multiple languages. Many caches in many climates. Teach skills that matter without machines alongside those that require them. Put repair before novelty. If others once climbed and slid, we can choose to tie ropes across the slick parts for whoever comes after us. The lesson is not despair. It is realism about how culture moves. It moves like a school of fish and like an old river that sometimes cuts a new channel. It leaves oxbows. It leaves quiet backwaters where rare things survive. If we search those bends in our species' story with the right questions, we may find proof of an earlier bend that the main current forgot. Stones tell one kind of story. Bodies tell another. Every person carries a library of lineages in their cells. The book is messy and full of edits. It still holds footnotes from meetings that happened long before writing and long before cities. People outside Africa carry a small share of Neanderthal ancestry, generally around 1 to 2%. Many groups in Asia and Oceania carry Denisovan fragments in different amounts. Some African populations show signs of admixture with unknown archaic relatives. These facts come from comparisons between ancient genomes and modern ones and from sequences pulled from teeth and bone and even cave sediments. They show encounters between branches of the human family tens of thousands of years ago. Genetics can time events with care and also with caution. Mitochondrial DNA tracks maternal lines. The Y chromosome tracks paternal lines. Recombining autosomes hold the rest. Statistical tools parse blocks of ancestry to date when groups mixed. A block that is long and uniform hints at a recent event. A block that is short and scattered hints at older meetings blurred by many generations. These clocks run with errors that grow with age. By 100,000 years the blur is wide. Some studies once proposed a severe population bottleneck around the time of the Toba eruption. Later work argued for a more complex picture with regional variability over long spans. The debate reminds us that genetic signals can be read in many ways. What genetics can say confidently is that our species met other hominins several times across Africa and Eurasia and made children who made more children. It cannot say whether any of those meetings involved a city on a vanished coast or a lab on a ridge of wind-carved stone. Still, the body can hint at behaviors. Genes that confer adaptation to high altitude in Tibetans look like a Denisovan gift. Lactase persistence that lets some adults digest milk spread in pastoral cultures over the last 10,000 years. Amylase copy numbers rose with starch-heavy diets. These are examples from recent millennia. If a group much earlier engineered plants or managed landscapes in consistent ways for long periods, selection could leave traces in genes linked to diet, disease resistance, and perhaps shifts in gut flora that match a cuisine. Ancient DNA from sediments adds a new kind of evidence. Caves that hold no bones still hold DNA from skin cells, feces, hair, and blood. Lakes can hold environmental DNA from fish and plants that people ate. If a cave long used by humans 100,000 years ago also contains DNA from crops that do not match the wild flora outside, we would have a mystery worth 1,000 shovels. The test would be strict and the chance small. The reward would be profound. Skeletal chemistry tells travel stories. Strontium isotopes in tooth enamel record the geology of the place where a child grew. Oxygen isotopes in enamel record climate and elevation. A person buried far from their childhood strontium carries a map inside their smile. In the Holocene we already see patterns of migration tied to trade and marriage networks that span hundreds of kilometers. Push back farther and the sample size shrinks, but the method remains. A cluster of individuals in a Pleistocene cave with enamel that points to childhoods across different valleys would imply movement and mixing that simple family bands rarely sustain. There is also a pattern in the shape of faces and skulls that reflects diet and tool use. Jaws narrow when people eat softer processed foods. Bones thicken along lines of stress when people carry loads or paddle or climb. These signals are not precise. They can still sketch lifeways. If a group in a warm coastal region shows shoulder and wrist adaptations common in paddlers and net fishers, that would match a story of water skill even if boats turned to soil long ago. Genetics can record population structure at scales that hint at social texture. High levels of diversity within a region suggest deep roots and mixing. Long runs of homozygosity suggest isolation or small founder groups. Sex-biased gene flow suggests rules about marriage and residence. In the Holocene we see male-biased movements in some expansions and female-biased movements in others. In older layers we see hints but not detail. A checkerboard of structure at 100,000 years ago could support a web of small communities that met and traded along coasts and rivers. There is a tempting hope that we might find an outlier genome that screams technology. That is not how DNA works. It does not code for calendars or star charts. It codes for proteins and regulation in timing. What it can tell us is whether a people lived in one place long enough for the land to shape them and whether their children moved in patterns that suggest exchange. It can also tell us who met whom and when in broad strokes. That is a map to lay under other maps. Ethics rises with the science. The bodies we study were people with descendants who may care how and where they are analyzed. Laws govern sampling and export. Communities have the right to say no. The best work proceeds by consent and returns knowledge and capacity to the places where the stories began. That is not an obstacle. It is a way to make sure that any revelation about deep time does not repeat old harms in the present. If a lost civilization existed 100,000 years ago, its genome would not carry a label. It would carry the same mix of chance and selection and kinship that ours does. The echo we might hear is not a fixed melody but a harmony between lines of evidence. A strange pollen layer in a core. An unusual chemical in an old mud. A set of teeth with strontium from far away. A song still sung about a shore that is now a line of blue on a map. Together these pieces can make a chorus that suggests more than chance alignment. The idea becomes work only when you can draw a map. Not a metaphorical one. A literal set of targets and tools and teams with boring checklists and precise logs. If the question is whether an advanced society could have risen and vanished 100,000 years ago, the answer lives in mud, ice, stone, and old drawers. Start with shelves that were once dry land. The Sunda Shelf between Vietnam, Borneo, Java, and Australia held rivers and plains when sea level stood lower. The Persian Gulf was a green valley that channeled the Tigris and Euphrates toward a smaller ocean. The North Sea hid Doggerland where elk and people crossed. The Arafura Shelf between New Guinea and Australia was a shallow steppe. Draw boxes around drowned river mouths and terraces shown by multi-beam surveys and set priorities where sediment is fine and steady and where buried river banks might have trapped wood, fiber, or shells that can still be dated. Use the right instruments. Multi-beam sonar maps the bottom in strips. Sub-bottom profilers send sound into the mud and trace buried surfaces. Chirp systems resolve the top tens of meters. Sparkers can reach deeper. Side-scan sonar catches textures that suggest walls or logs. When a target looks promising, drop a vibrocore or a piston core and pull a meter or 10 of layered history. Photograph every centimeter. Log color and grain. Split samples for chemistry, pollen, charcoal, microplastics, and radiometric dating. Map closed basins that keep clean pages. The Black Sea deep waters lack oxygen and hold timber for millennia. The Baltic has pockets of quiet mud. The Eastern Mediterranean hosts sapropel layers tied to monsoon pulses. Mark transects from shelf breaks into deep water and core along them to connect coast stories to offshore records. A terrace that steps down the slope can be matched to a terrace on land if dates align. That match turns two hints into one line. Move inland to lakes with still bottoms and long memories. Lake Suigetsu in Japan. Lake Van in Turkey. Lake Malawi in Africa. Deep small basins with seasonal stripes that rarely mix. Take overlapping cores to avoid gaps. Anchor every depth to a calendar with varv counts and radiocarbon or uranium series where needed. Scan with X-ray fluorescence to see element changes before you cut. Flag layers with odd carbon or nitrogen ratios. Pull samples into clean labs for gas chromatography and mass spectrometry. Build reference libraries so that future teams can compare their finds to a shared baseline rather than starting from zero. Add caves where humans like to rest. Map systems above fertile valleys and near old coasts. Sample floor sediments for ancient DNA with strict contamination controls. Collect speleothems and read their trace elements for land use changes above. Excavate with microstratigraphy and keep every ash lens separate. A cave that shows human presence in the right window and a shift in outside pollen without climate drivers is a node to circle on the big map. Scan museums and storage. Build a program to reanalyze resins, fibers, and composites from sites older than 10,000 years. Use Raman spectroscopy to fingerprint polymers. Use pyrolysis gas chromatography to read molecular fragments. Many small oddities will turn out to be natural. A few will not fit known materials or known ages and will demand a return to the field log and the layer where they came from. Bring computation to the cores. Machine learning can spot subtle multi-marker patterns that single plots miss. Train models on known industrial signals from recent centuries and on natural events like wildfires and volcanoes. Turn them loose on older cores as anomaly detectors. Every flagged layer becomes a hypothesis to test with independent labs. Publish negative results. Build a shared database where other teams can add and challenge. Feed in bathymetry and sub-bottom lines and let algorithms propose buried channels and terrace lines for the next crews to test. Use robots where divers cannot go. Remotely operated vehicles can fly sonars along slopes and hover over targets to drop markers. Autonomous surface craft can run long straight lines in bad weather and tow sensors with perfect patience. Gliders can profile water chemistry for hints of methane seeps or freshened lenses above ancient channels. Every machine extends the reach of the slow human work that follows on deck and in labs. Work with fishers and divers and cavers. Trawl nets bring up bones and timbers from places no academic boat has mapped. Free divers see ridges and holes that echo old streams. Speleologists know which hills breathe cold in summer and which drips change when snow melts. A photo and a GPS point from a trawler can save a season. A caver's sketch can decide where to place a trench outside a mouth. Train local crews to log and sample with the same care as ships so that chance finds become data rather than stories that fade by winter. Design the chain of custody before the first sample. Loggers sign every bag. Labs record every step. Cross-check dates in independent facilities. Deposit splits in public repositories. Invite skeptics early and give them the same mud. The goal is not a splash. The goal is a record that holds when a decade has passed and when new teams repeat it. Budget years, not weeks. Field seasons fail. Storms keep ships in port. Cores break. Permits take patience. Funders like quick wins. The wins here will be maps and methods that improve many sciences, even if the big answer remains maybe. Be honest about that when you ask for ships and drills and time. Add training lines to proposals so students from the region studied gain skills and careers from the work. Look for convergences. A shelf core shows a century of odd carbon. A nearby lake shows heavier nitrogen in the same window. A cave in the same watershed shows human presence. A museum drawer holds a fiber from a deep layer at the delta mouth with a dye that puzzles chemists. No single piece convinces. The pattern does. Demand at least 3 lines of evidence that point to the same years and the same basin before you whisper the word civilization. Finally, plan for open eyes. If you find nothing beyond nature, say so and say why that answer teaches. If you find hints, share them with the care you wish others had used before you. If you find something that looks like a fragment of a world that had different rules, slow down and let many hands test it. This is not a race to plant a flag. It is a long walk across a foggy plain where one steady step matters more than a sprint. The map exists to be used. It is also a promise. We will learn more about the planet either way. We will close blank spaces on the human chart whether anyone lived there with gears and calendars or only with baskets and songs. The search honors both possibilities without prejudice. It is how grown-ups explore. Imagine a morning when a small lab posts a preprint that shows a suite of non-natural fluorinated compounds in a dated layer near 100,000 years old from 3 cores taken far apart. The spectra match. The dates match. The labs are independent. The molecules should not be there. Within hours other groups pull dusty samples from freezers and test them. Within days several confirm. The news is not a statue. It is a graph. It is also a bomb under our neat story. The first reaction is excitement. The second is defense. Some will argue contamination. Others will argue misdating. A third group will argue that volcanoes can do weird chemistry. A fourth will try to replicate with new cores and new controls. The debate will be loud and healthy if we let it be. It should also move to a slower rhythm than a news cycle allows. Good science prefers months to hot takes. Media will bend the arc, headlines will jump from cautious maybe to absolute yes and then to smug debunking and back again. The right answer is a plain voice that repeats what we know and what we do not. The right pace is set by ships and labs, not by feeds. Scientists can help by writing for the public in ordinary words and by refusing to turn uncertainty into theater. Museums will feel the tremor. Curators will reopen boxes from old shelf surveys. Labs will rerun odd fibers and resins from deep layers. Funding agencies will call meetings. Naval survey archives with seafloor maps will find new readers. Shipping lanes will become transects for science. The map we sketched will fill with pins and ships and cores. There will be politics. Maritime claims already tangle coasts from the South China Sea to the Eastern Mediterranean. A hint of deep human history adds a new kind of heritage to argue over. Nations will speak of stewardship. They will also think of prestige. The best guard against conflict is openness. Share coordinates. Share methods. Share samples. Spread the work across teams with roots in the regions where the layers lie. There will be belief systems that feel challenged. Some will see the finding as proof of myths. Others will see it as a threat to traditions that tie identity to specific origin stories. It helps to remember that older does not mean better or worse. It means broader. A deeper human past does not erase recent sacred histories. It frames them inside a longer home story. Many traditions already speak of cycles and floods and lessons. A real deep past brings those lessons into a new light rather than turning belief into argument. Education will need new pages. Timelines in classrooms will earn extra lines. Teachers will need ways to hold wonder and caution together. It is easy to turn a deep find into a movie. It is harder and better to turn it into practice in labs and in field schools that invite students to core and to read mud. The next generation will inherit the work either way. We should give them tools instead of myths of certainty. Law will have to keep up. Underwater sites sit under different regimes than land. International conventions protect wrecks and heritage. Few cover Pleistocene shorelines that are not countries now but were once lands where people lived. Agreements will need language for cores and for rights and for sharing. Communities near coasts will need voices in the process. Their stories may point to shelves worth coring. Their fishing lives will be affected by ships that come to drill. Technology companies will circle. Sensors, robots, and data platforms will find a market in dredging the past from mud. That is not bad if the terms are fair and the data stay open. Beware of proprietary black boxes that hide methods. A claim about the oldest anything must be testable by a lab with fewer resources on a different continent. If discovery becomes a product, trust will fail and the work will slow under suspicion. Universities will need to build new bridges. Archaeology, geology, chemistry, genetics, and oceanography will have to share budgets and rooms. Tenure committees will have to value slow team science over single author speed. Reviewers will have to learn to read outside their comfortable literatures. The reward will be a field that can carry a heavy question without dropping it whenever a fad passes. There will be art. Writers and filmmakers will fill the gap between data and imagination with faces and cities and songs. Some will be careful. Some will be loud. The careful ones can help by carrying the discipline of the field into story. The loud ones will help anyway by bringing more eyes. The best defense against nonsense is a steady stream of good plain language from scientists who respect the public enough to explain without sneer. The biggest risk is not that we are wrong. The biggest risk is that we are right and we mishandle the weight. A discovery that rewrites human self-image should humble more than it divides. The right response is patient, transparent, and generous. Bring many hands. Share credit. Admit doubt. Protect sites. Protect people. Leave room for the parts that may stay unknowable even after the signatures are clear. If proof arrived tomorrow, by evening headlines would shout a century-old sentence. We were not the first. The real work would begin the day after, when the ships sail and the cores come up and the graphs turn into a geography we can teach and live with. The shock would fade. The map would grow. The story would become ordinary, and that is the best fate for any truth. Return to the drowned plain at dawn. Fog lifts in strips and shows sand ridges that used to be dunes when winds blew across Doggerland. The tide is moving and a trawler works a net where reindeer once crossed a marsh. The deck is wet with spray and with memory. A bone catches the mesh and taps the rail. It is small and smooth and human. The hook that opened our story still holds. What if history is wrong about where complexity begins? After 12 parts, the question is less a shout and more a working plan. We know sea levels rose in pulses. We know ice needed continents. We know chemistry can store whispers longer than stone. We know caves and lakes and permafrost keep rooms where time forgets to sweep. We know myths sometimes carry maps. We know bodies carry paths. We know skill can climb and fade and climb again. The center of the story remains simple. Could an advanced society have existed 100,000 years ago and left so little that we have not known where to look? The answer today is not yes. The answer today is not no. The answer today is a map and a method and a willingness to test without vanity. That is how you treat a mystery you want to solve and not only to enjoy. We have walked through coasts no one draws and through chemistries that do not forget. We have stepped into vaults of ice and mud and caves that breathe quiet air. We have watched worlds reset under ash and wave and drought. We have seen knowledge lose its balance and then find a new one. We have listened to genes and to bones and to pollen and to soot. Each piece alone is a question. Together they are a path. The path bends toward humility. We are not the top of a ladder. We are a branch on a tree that has dropped limbs before and grown new ones. We live on a planet that recycles its own skin. We build in materials that time eats. We tell ourselves we are permanent while knowing we are not. To carry that knowledge without despair is a kind of adulthood for a species. There is a practical end to this meditation. If we want our work to be legible to a reader 100,000 years from now, we must choose what to write and where. Stone still speaks when cared for. Chemistry still whispers when protected from air. Knowledge still survives when spread across many places and many minds. Design archives that do not assume continuous electricity. Build caches above flood lines and below fire lines. Teach repair along with design. Practice small grids that can stand alone when the big grid fails. There is also a gentler end. If an older world chose lightness over monuments, it may have known something we forgot. A civilization that refuses to leave ruins is not a people without art or science. It is a people who placed resilience over spectacle. We could learn from that choice without needing to prove they existed. We could choose durability over display. We could write our pride into soils that stay fertile and into rivers that still run clear after our great-great-grandchildren plant new fields. Stories are tools. The story you hold now can help build patience for slow science and respect for the unknown. It can also help build policies that protect shelves and lakes that look like empty blue on a map but are actually libraries. It can give reason to fund cores and to train hands that can read mud. It can even give comfort when headlines sell certainty. The deepest truths often arrive in whispers from places without cameras. A last twist waits in an unromantic place. The catalog number on a bag in a small museum could change everything. A student could test a fiber from a deep layer and see a spectrum with lines no plant makes. A diver could photograph a terrace with post holes in a depth where waves cannot shape them. A corer could pull a cylinder that shows a thin band with a chemistry that matches nothing we know. The door we have knocked on for 12 parts may open with the softest sound. Walk back to the rail. The trawler swings and the sun burns through the fog. Somewhere under the hull a river from a colder age still runs as a shadow cut into sand. We are late arrivals on this stage. That should not shame us. It should steady our hand. We will write our chapter. Time will edit it. The best we can do is write clearly and leave the next reader something true to hold. If others wrote before us, their words are buried in places we can reach if we are patient. If none did, the search will still teach us how the earth keeps its own minutes. Both outcomes are gifts. Both shrink our pride to a size that fits a moving planet. That fit is the oldest lesson and the newest one. It is a lesson we can carry without proof because it improves our work even if proof never comes. We end where we began, with a wind over a coast no map shows. The question remains, and that is not a failure. It is an engine. It turns curiosity into field notes and field notes into knowledge. It turns a neat line into a wider circle. It turns us from owners of the past into readers. That is a better role for a species that lives by stories and by care.